Hello, welcome to the fourth unit, Multivariable Differential Calculus and Function Optimization. In this video, we are going to see about the Jacobian. First, we will see the definition of Jacobian. So, if u is a function of two independent variables x and y, and v is another function of two independent variables x and y, and these two are continuous functions of the independent variables x and y, such that the partial derivative of u with respect to x and u with respect to y. Similarly, partial derivative of v with respect to x and v with respect to y are also continuous in x and y. Then the Jacobian of u and v with respect to x and y is defined as like this. So symbolically we will write j, capital J. So in brackets we will write u comma v, x comma y. In the bottom we will write x comma y. Or this notation also we will write partial u comma v by partial x comma y. So the definition of this is, you have to do first partial differentiation of u with respect to x. So dou u by dou x, this one, dou u by dou y, next dou v by dou x, dou v by dou y. So the value of this determinant is nothing but Jacobian of uv with respect to x and y. So the same formula is extended for three variables. Similarly, the Jacobian of u, v, w, w is another variable, with respect to x, y, z is defined as like this. The same notation, here two variables, here three variables. So therefore here it is a 2 by 2 determinant, here it is a 3 by 3 determinant. So u sub x, u sub y, u sub z. Next v sub x, v sub y, v sub z. Next w sub x, w sub y, w sub z. So the important application of this Jacobian we'll see in multiple integrals in the concept of change of variables. Okay. So here there are two important properties of Jacobian. The first one is this one. So if J is Jacobian of uv with respect to xy and J dash is Jacobian of xy with respect to uv, then the product J dash is 1. Similarly, the another one is, if u comma v are functions of r comma s and r comma s are functions of x comma y, then if you want Jacobian of u and v with respect to x and y, then you can use this chain rule. Okay, so what is this one is u v with respect to rs, then rs with respect to xy, right? If you see, if these two gets cancelled, you will see this one only. Okay, so this is known as the chain rule. We are not cancelling here, that is not the meaning. Okay, so this is known as chain rule for Jacobian. So these are the two important properties of Jacobian. Now we see problems on this. U is x square minus 2y, v is x plus y plus z, w is x minus 2y plus 3z. Then find Jacobian of uvw with respect to xyz. So what is given? uvw is given. So to calculate this by formula, what you require? U sub x, u sub y, u sub z. That means partial differentiation of u, partial derivative of u with respect to x, with respect to y, with respect to z. That's the first row. Similarly, partial derivative of v with respect to x, with respect to y, with respect to z as second row. Similarly, partial derivative of w with respect to x, with respect to y, with respect to z as third row. So we require these 9 derivatives. So u, v, w are given. So first we are calculating partial derivative of u with respect to x. Then this becomes 2x. With respect to y, this becomes minus 2. With respect to z, there is no z here, it is 0. Similarly, v with respect to x is 1, with respect to y is 1, with respect to z is 1. Similarly, w with respect to x is 1, w with respect to y is minus 2, w with respect to z is 3. Now we got all the 9 derivatives. We will substitute all these derivatives here in this formula. So we got this one. Now I have to expand this one. So if I expand this as a 3 by 3 determinant, it is very easy to expand. You will get 10x plus 4. So that is the value of Jacobian of uvw with respect to x, y, z. Next, the second question. If u is x plus y plus z, uv is y plus z, uvw is z, then prove that Jacobian of xyz with respect to uvw is this. Okay. So uvw, so this is given. This one is given. Here we written this one. So what I require is Jacobian of xyz with respect to UVW. Okay, so that means I require xyz in terms of UVW. So this, but here they given u is this one, uv is this one, UVW is this one. Z is available here directly in terms of UVW. Similarly, I have to calculate y in terms of UVW. Similarly, x in terms of UVW I have to calculate. So first I am taking this one, uv is y plus z. So from this, what is y? Uv, this z goes to this side, uv minus z. Now uv minus, but z is given for us, uvw. So uv is common, so which is 1 minus w. So now y value is what? uv into 1 minus w. So that means y is available in terms of uvw clearly. Next I will take x plus y plus z is u. From this, what is x? U minus of y plus z. But y plus z is what? uv. So u is common, which is 1 minus v. So now x value is u into 1 minus v. Y value is uv into 1 minus w. Z is already directly given. So now I can calculate this Jacobian. So first I have to calculate dou x by dou u. So where is x? This one. So dou x by dou u is 1 minus v. Similarly, dou x by dou v is u minus uv it becomes. So for u it is 0, minus uv means minus u. Next, dou x by dou w. There is no w here, 0. Next, dou y by dou u is v into 1 minus w. That is v minus vw. Similarly, dou y by dou v. Dou y by dou v is u into 1 minus w, that is u minus uw. Next, dou y by dou w. So for uv it is 0, minus uvw it is minus uv. Finally, dou z by dou u is vw, dou z by dou v is uw, dou z by dou w is uv. So now all the 9 derivatives are available. We'll write the formula and I will substitute all these values here, and if you expand this 3 by 3 determinant, you can see easily it is u square v. Next, if you see here, if x is uv, y is u by v, then find Jacobian of xy with respect to uv, and j dash is Jacobian of uv with respect to xy. These two I have to calculate, and I have to show that j dash is 1. So this is one property which we have seen already. So what is x? X is uv, y is u by v clearly. So I am calculating first this one. So for this, what we require? Dou x by dou u, dou x by dou v. So dou x by dou u is what? V. Dou x by dou v is u. Next, similarly, I want dou y by dou u. Dou y by dou u is 1 by v. Dou y by dou v is minus u by v square. So therefore, our j is Jacobian of xy with respect to uv. So the formula is this one. So I substituted all these 4 values here, v, u. So if you expand this, minus u by v square into v is minus u by v. Next, this is also minus u by v. So minus 2u by v. Next, I require u with respect to x. Similarly, dou u with respect to y. So for that, we have to write u and v in terms of x and y. So see clearly here, x u square is xy. How we got u square is xy from 1? From 1, what is u? Y v. But what is v? X by u. So from that, u square is xy, or otherwise you can write like this: u is here x by v, and u is here vy. So if you multiply both, u square equals to x by v into yv becomes vv gets cancelled, xy, and v square I want. What is v? V is here x by v square we want, right? So from this you can calculate v square very easily. So what is v from this? X by u. If you calculate v from this, u by v. So v square means just product u by y into x by u. So it becomes x by v. So now I am calculating dou u by dou x. So how to calculate dou u by dou x here? 2 times u comes here, dou u by dou x equals to, this side it is y. So that 2u sent to this side. Similarly, dou u by dou y is 2u, dou u by dou y is, here it is x, so that 2u comes to here. Next, dou v by dou x is 1 by dou v by dou x. That means 2v into dou v by dou x equals to x by 2vy. Next, 2v into dou v by dou y is minus x by v square. That 2v came to this side. Now, if I substitute in j dash all these four values, it will be like this. So, if I expand this one, minus xy by 4uv y square. Y gets cancelled, we will get minus x by 4u vy. Similarly, this becomes minus x by 4u vy. So, minus x by 2u vy it becomes. So, what is x by y? X by y is nothing but v square comes. So, 1v cancel minus v by 2u. Therefore, j dash is, j is this value, j dash is this. If you multiply this, it is 1. So, clearly it is 1. So, according to property also it is 1. Next, if x equals to r cos theta, y is r sin theta, then find Jacobian of xy with respect to r theta and r theta xy, and hence show that j dash is 1. Okay, the same type here it is. So, given x is r cos theta, y is r sin theta. So, in order to calculate this, we require dou x by dou r, dou x by dou theta, dou y by dou r, dou y by dou theta. All these four derivatives are calculated here. So, substitute in the formula, expand it, you will get r cos square theta plus r sin square theta is r. Next, to calculate this, what I require? Dou r by dou x, dou r by dou y, dou theta by dou x, dou theta by dou y. So, for that, we are using this. R square is x square plus y square and theta is tan inverse. So, from that, we calculated dou r by dou x, dou r by dou y. Similarly, dou theta by dou x, dou theta by dou y. So, if you substitute in the formula, it will become like this. So, if you expand this, what you will get? X square by root x square plus y square into is 3 by 2 plus 3 by 2. So, LCM is same. So, x square plus y square, which is nothing but r square by r square, 1 by r. So, which is 1. Next is this is chain rule. U is this, V is this, X is r cos theta, Y is r sin theta. He is asking this one. So, this we can write it as by using chain rule. UV with respect to r theta, I am writing it as UV with respect to XY, XY with respect to r theta. So, first I will calculate this, next I will calculate this, the product gives this one. So, to calculate this, what we require? Dou u by dou x, dou u by dou y. U and v is available. Dou u by dou x is 2x, with respect to y, 2y, with respect to x, v, 2y, with respect to y, v, 2x. So, we can calculate first that one. So, according to that, we will get 4r square. Next, I require this one, second one. So, for that, we require dou x by dou r, dou x by dou theta, dou y by dou r, dou y by dou theta. So, all that thing is calculated here, and if you substitute, you will get r it is. So, finally, dou u by dou Jacobian of uv with respect to r theta is this into this 4r square into r, which is 4r cube. So, which are very simple problems. Okay. I am Srikanth Reddy. Thanks for watching. I will see you in the next video.